at solutions to homework problems, and we're starting with the cards in homework 5. Okay, to review how this is supposed to be, how this is laid out, what's the structure, what's going on. We're keeping a list of numbers from 0 to 51 and thinking of those as cards because there's 52 different cards in a playing card deck. There's 4 aces, so ace of hearts, ace of diamonds, ace of spades, ace of clubs, and ace means 1 in playing cards, and a 2 of hearts, 2 of diamonds, 2 of spades, 2 of clubs. Then there are 4 different 3s as well, a 3 of hearts, a 3 of diamonds, a 3 of spades, a 3 of clubs, and so on. There's 52, and I'm thinking of, I'm just going to store a number from 0 to 51. And the last number, if I'm laying things out like this, would be a king of clubs. All right. So instead of storing this whole thing, I could store this whole thing, but the way I wrote the code is we're just storing the number, and then given the number, we can compute the number on the card and the suit. So I have a couple of examples here. So first I have the ordering that I'm using is I'm thinking of a 0. So I'm starting with hearts. So the way I actually compute that is I divide by 4, and what's the remainder? So if I get a 0 remainder, that's hearts. 8 divided by 4 is a 0 remainder, so that's a heart. 12 divided by 4 is 0, so that's a heart. So that's what I'm thinking about, that if I have my card number, if I divide by 4, whatever the remainder is, if it's a 0, I'm calling that a heart. If the remainder is 1, I call it a diamonds, 2 spades, 3 clubs. Okay, so that's one part of what is the actual card. And the other part is I put my aces first. So the first 4 numbers are aces. The next 4 numbers are 2s. The next 4 numbers are 3s. And the formula for that is if I divide by 4 and round down, so if I divide 0, 1, 2, 3, if all of those divided by 4 are 0. So I divided by 4 with a 0, I'm calling that an ace. If I divide by 4 and round down and I get a 1, I'm calling those 2s. And then 3s, and then 4s, and so on. And the kings would be at the end. So 51 divided by 4 is 12, remainder 3. So 12 is a king, remainder 3, I'm calling a club. Here are some examples. Let's see if they are correct. So if my number is a 13, to convert that into the card, suit, and number, so 13, if I divide by 4, I get a remainder of 1, and the quotient is 3. So a remainder of 1 says it's a diamond, and I have that written out here. And a quotient of 3 says it's a 4, which I have written out here. So that 13 is really a 4 of diamonds. Let's see about 26. So 26 is 6 times 4 plus 2. So the 2 says we're a spade, and the 6 for the quotient says we're a 7. Because if I copied and pasted this all the way out, then that's just the order that I have them. Another example here. So 8, the remainder is 0, so that's a heart. If I divide by 4, I get a 2, and so that means it's a 3. Okay, so that's individual cards, and then a hand, I'm just keeping those numbers. So this hand here is really a, let's see, 4 of diamonds, a 3 of hearts, and a 7 of spades. And if I put a 10, let's see, what are we going to get? I divide by 4 with a 10 and I get 2, which is a 3 of, if I do a remainder by 4 here, I get a 2 as well. So that's a spade. Okay, so we have these numbers which we can think of as cards like this. We have hands which are just lists of those numbers. And I want a function, 2 different functions. One is to determine whether a hand is a flush. So a flush is all cards are the same suit. A pair is at least 2 with the same number. Okay, so let's talk about flush first. So first we have some examples of hands that are flushes. If our hand is 0, 4, 12, 0 is an ace of hearts, 4 is a 2 of hearts, 12 is a 4 of hearts. So those are all hearts. The flush would be true. And if we go over into the code that you were given, you were told to copy paste. So this is copy pasted. There were print decks here that I commented. We're supposed to do the flush command, so you can ignore this code for a second. But for doing the flush command, there were some examples here. So this, the claim is this should be considered as a flush because those are all hearts. This one here, what are the remainders? If I divide by 4, I get a remainder of, let's see, 15, I get a remainder of 3. 7, I get a remainder of 3. 19, I get a remainder of 3 as well. And what were those? Clubs. So these are all clubs. So I should get 2 trues. This one here, 0, 1, 2, that is a heart, a diamond, and a spade. Just the first 3, heart, diamond, and spade. That should give us a false if the function is correct. This here, we have a heart, and 13 has a remainder of 1. That's a diamond. So the definition of flush says all the cards have to have the same suit. This should give a false. So if our code is correct, we should get trues on both of these and falses there. I'm going to run it. Right now it says false on all of them because I don't have my code in there. Okay, so the idea, and I'm just going to look at it over here. So the idea here is I'm going to check, so the idea or algorithm for checking for flush is check first and second, second and third, third and fourth, and so on. Okay, so for this example, I'm going to check the suit of the 0 and the suit of the 4. So what is the suit of the 0? That's a heart, and this is a heart. So I would say same. Then I'm going to check the suit of the 4 and the suit of the 12. That's a heart. That's a heart. They're the same. If I take another example, let's say I wanted to look at flush 0, 4, 9. Okay, I'm going to do the same thing. I'm going to check the suit of the 0 and the suit of the 4. That's a heart. That's a heart. They're the same. Now I'm going to check the suit of the 4 and the suit of the 9. 9, 4 is a heart. What is the suit of the 9? That is, we're considering it as a diamond because it has a 1 remainder. These are not same. Okay, so then the answer for the answer should be false on this example. Okay, so I want to compare these, and then I want to compare these, and if I ever get that they're not the same, it's not a flush. So the loop for that, I want to look at for I in range 1 up to the length of my hand. If card I, this is going to be pseudocode. So is the same suit, let's see, if the card I, it's actually easier just to do it like this. So this is the suit, and I can test whether they're equal or not. So if they're the same, what do I know? It might be a flush. But if they're different, I know it's not a flush. So that's the logic. If we're inside of this loop, we're checking the ith card, the suit, and the I minus first card, the suit. If we're checking those and they're different, this hand is not a flush. So we can return false because we don't have to look at the rest once we find 2 cards that are different. If we get done with the loop and we never returned false, if we made it here, never returned false, so all cards are the same suit. Right? We checked the first and the second, they were the same. We checked the second and the third, they were the same. If there were more cards, we checked each pair, and they were all the same. And if we make it here, we never stopped, because if we return false, that's done. It's done. We would never get to the return true. All right, so that's the idea. And then I have it already typed in over here. And I could run my code, and I should see a true, true, false, false. I'm also going to print the deck of the first example. So ace 2 4, is that what I thought it was? Ace of hearts, 2 of hearts, 4 of hearts, and I got a true, true, false, false as I thought. So you would want to try out other examples as well. You could try it by modifying here or adding another one here. So we could say make a new hand. So here's another hand I could call flush of that. Should that be a flush? Well, let's print the hand. So whatever these values are they all the same suit? So I picked a spade, a diamond, 2 hearts, and a club. But you could modify that and put other values in and make sure it always gives the right answer. So you could print the hand, run your flush function, and try different ones. For the pair function, I want to look at least 2 that have the same number now. So instead of looking at the suit, I'm looking at the number. So let's say our hand is, we'll take one of the examples here that says it should be a true. So this one here, let's look at it. So I'm going to print the deck. The last deck that I print will be this hand. Okay, so if I believe that the code is working there, so if I have this, if I have these cards, so what I'm going to, my idea is I want to sort these. So if I put these in my order, let's see, 2's less than all of those, and which one comes first in the order, diamonds or spades? According to this, diamonds comes before spades. So if I order them like this, I would have a 2 of diamonds, then a 2 of spades, then a 6 of hearts, then a king of hearts. And I can just sort them based on number. So the numbers for that was this, and you could run the remainders and quotients to make sure that you agree with that. So those are the numbers, and then if I put them in sorting order, this would be okay, so if I just sort based off the number, it'll put them so that they would look like this. Alright, so then what I want to do is I want to check is 2 of diamonds same value as 2 of spades? Yes, so return true. If I take another one, let's take this one here. So this one here is going to be an ace of clubs. That's what a 3 is. A 4 is going to be a 2 of hearts. 25. We're going to get a 6 remainder 1 when we divide by 4. So let's look up here. 6 is a 7, remainder 1 is a diamond. So 7 of diamonds. So what my code is going to do is I'm just going to compare each adjacent card after I sort them. These are already in sorted order, so I would check is an ace of clubs, same value as two of hearts? No. Is the two of hearts same value as seven of diamonds? No. So therefore I'm going to return false. Okay, so for a flush, I'm comparing each card and saying, are they the same suit? These are not, so this is not a flush. For a pair, I'm looking for the same value. Is this the same value? No. Is this the same value? No. Is this the same value? No. And if I get through and they're all no's, then I would return false. For this trick to work, of just comparing adjacent values, I have to have them already in order. So I'm going to sort my hand based on the number on the card. So then, if I have a pair, they should be next to each other. Okay, so for the pair, you're going to have a function that's similar to the flush. You're going to go through each adjacent numbers. The difference is you first need to sort the cards. And then your condition here, instead of taking the remainder, you want to take the quotient. And the condition here is going to be different as well. So instead of this, we'll have, if the numbers are the same, we return true.